Thank you very much. Well, for me it's a pleasure to be here, right? Most of you know that's something like being at home a little bit, right? Back off. Okay. Yeah, I tried to give you a short overview on what's going on and that you have a better feeling on why you should trust that technology. But first of all, really my message is at the very first begin, please clean up your brain. OPC UA is not just a protocol. You are not here to learn about the protocol. Because that was a little bit the question. Also, okay, there are so many initiatives and cloud initiatives, how can we move data from here to there? So clean that for a while and then start fresh with some ideas. Exactly, OPC UA, UA stands for Unified Architecture. It's not Unified Protocol, right? And the Unified Architecture means it provides you, first of all, and I think this is the highest value, security and reliability. You as a machine builder, you want to protect your data and you want to exactly provide who is able to get and read and write what kind of information from my machine. This is key. And then, of course, yeah, you need something which is international. It's not German. OPC UA is not German. It's international. It's an IEC specification. It scales from sensor to cloud. It's completely independent. Maybe that's also high value. It's not owned by somebody. No company can really dominate the direction of OPC. And then, of course, we move data and information from left to right and up and down. And we do this on with different mechanisms, because what we figured out is something what you need inside the factory is maybe something completely from connectivity point of view different than you need something from sensor to cloud. And that's why we have exactly different protocols, TCP, UDP, AMQP and so on, which is available. But again, this doesn't affect anything. Your data is moved. Just quick overview. I think 2 years ago when I have spoken here, we nominated SAP to the board of directors because we wanted to grow from the automation world into the IT world. And into this direction, into this strategy, we nominated now also Microsoft to be on the board. And that's why also here today we have a Microsoft speaker. So together with Matthias Damm from Aesculap, we have here today in this room 3 board members. And I think this is good commitment. Okay, OPC UA in the world, a lot of, well, I think it's maybe even more press people believed and made articles on OPC UA is more European driven, factory manufacturing driven, and in US it's different. There they have the Industrial Ethernet Consortia and they do whatever else protocol. And my message here is that's not true. You cannot compare that in this easy things. Sometimes the world is not that easy. Journalists sometimes want to have it easy and want to get a sensational message, right? The Industrial Ethernet Consortium is listing 5 protocols where they say these are the protocols which we are looking deeper in the future. And they are listing MQTT, they are listing CoAP, they are listing DDS, they are listing OPC UA, they are listing web services. That's all in their reference architecture. But then the Industrial Ethernet Consortium is not doing any standard on its own. They are just providing a testbed platform where companies, even competitive companies, come together to join and test something. And so there are also a couple of testbeds which are based on OPC UA. Right now I'm aware of 3 test beds. One is about Bosch and KUKA, about OPC UA and TSN, hard real time. The second one is pretty new, so Miriam Schleipen will talk later on Automation ML. So there's a new test bed about Automation ML and OPC. And this is something which is also initiated in Germany, that's true, by TE Connectivity, IFM, SAP with the help of OPC Foundation. They are doing a gateway, an IO-Link module in the middle. They not only want to move data from IO-Link level into the PLC, they also create an OPC UA server inside to share the data outside to cloud systems, to move sensor signals directly into the cloud. The sensor people want to earn money on providing their data. not only to the PLC, but providing additional information to somewhere. Data is a currency of the future, and so they want to participate on that. In the German Industry 4.0, that's true. OPC UA today is the one and only recommendation for communication. That's here in this paper, in the status report. It's published in July 2015. So it's not on the roadmap, it's already written. And here you see there's one statement, please make use of OPC UA for the communication. Interestingly, and you see I have copied that slide from Mr. Hankel from Bosch Rexroth. He made a presentation at the OPC Day Europe, and he's in this Industry 4.0 consortia, and he was exactly giving a more detailed insights on what is the status of Industry 4.0 today. And his message was, hey, there are 3 steps: Industry 4.0 basic, ready, and full. And today you can really reach the level of your machine is Industry 4.0 basic. You can call your machine like that if you fulfill 7 requirements. And one of that 7 requirements is you have to make use of OPC UA. Okay? If you want to get the full detail video, we recorded the videos, not only this one, also about more, also on the results of the security analysis from the German BSI and much more. So Eric's presentation at the OPC Day has been recorded, Matthias and all the others, which we will publish more and more now. Then just go to that URL. I guess you get the slides later on anyway, and you can go there and download and look and review the videos. Okay, for a machine builder or a device manufacturer, what is most important? You want to bring your machine, your device into an IT environment, and again, what is most important? Yeah, you want to be connected, of course, sure. Well, that's a goal, but this is not. Of course, you want to be securely connected. Again, what I mentioned, data is your currency. You do not want to share all the data. From my history, I know that an injection molding machine has about 1 million PLC variables. You do not want to share that 1 million variables to the outside world. You want to share 30 of them to the MES system. You want to share 2,000, 3,000 to the SCADA system. And of course, your service support engineer, he needs to have full access to everything. So this is the outer layer, the blue line. Transport security. Then below that, behind that, we want to talk in information models. My message is just moving data from left to right, as I did when I was young and unexperienced, and we were talking with Modbus and Aircraft 512 and stuff like that, right? We always had to agree between human beings on what is the meaning of the data. Okay, the bit 1 is meaning this, and if you confirm with the second bit, then I write my status in byte number 3. That's exactly 20 years ago, right? And this is history. We want to have a clearly description and the meaning of the data. So we need information models. And then we have a lot of services behind, live data, historical data, and so on. And then the device might have an operating system in the middle, it might have real-time. But do you know, you see nothing from that to the outside world. Of course, you need interoperability to access that services, and this is exactly what OPC is about. Because of the relevance of OPC UA for the German industry, the Federal Office of Information Security analyzed for 1.5 years OPC UA, and the results are completely public on the BSI and the OPC web. Everything what they found 1-2 critical things which we already fixed long time ago, but we are proud that we got this review and that they confirm overall the only communication technology what we know which is secure and so on is OPC UA. So you can read that in later on. This gives us really a good base that this is a good base for a secure manufacturing environment. Okay. And then exactly that was a question of one attendee here. So there are so many cloud activities and everybody has its own protocol. So what is the right? Which one should I use? And this is really making me a little bit crazy. So should I use MQTT or AMQP or OPC UA? And again, you are comparing something which you can't really compare. OPC is much more than a protocol. We see later on Matthias' presentation that even OPC is running over MQTT or over AMQP. So you cannot say this or that. But OPC provides again more information, the metadata, the meaning of the data. Because if you put just this one, whatever protocol, there are so many agents outside. Everybody says, put my agent into your device and then you're connected, right? So I was traveling in India and Pune, and an English student says, hey, I integrated the Intel IoT SDK into my Raspberry, and now look, I can talk to the Intel cloud. I say, yeah, great. But that device would never ever be out of the box be able to talk to the Microsoft Azure or the SAP HANA cloud. So what is the value of just implementing one thing? You as a machine builder would have to implement 3 different protocols or 5 different SDKs to always meet what is required in your project. So all these protocols don't provide interoperability. They are just moving data, and that's not enough. Okay, so how do we connect the brownfield environment, so existing factories and modern devices? Well, of course, and I added, of course, a little bit, because we are here at Backoff, a little bit Backoff devices here. Because it's all the PC-based control devices have the benefit, okay, they can include all kind of drivers and all kind of connectivity. So here you see OPC UA via AMQP has been shown already public. It's possible, yes. But does it make sense to really, you have a huge production line and there are, let's say, 40 machines. Do you really connect each of the 40 devices directly to the cloud and handle security always one-to-one between each of the 40 machines to the cloud directly? You would not. Because the handling of that is much too complicated. Instead, what you would do is you would make use of a gateway saying, I put this gateway in front of my machine line, and this gateway has all the security to the upper cloud and IT layer, and the gateway has all the certificates and all the handling to the lower machines. And I have one central point here. And of course, the gateway can talk via OPC UA to the underlying systems, that you really have security on each level. And that makes sense, and I think this is a trend for the future. Okay, gateways. There are a lot of gateways. So if you, again, if we talk about the brownfield environment and you want to connect whatever, Siemens S5, S7, just make use of this IBH Link adapter. You can connect 3 Siemens devices. It's about, well, 500-600 euro, and that's it. For the Rockwell World, same. There are devices on the market available to just connect them quickly. But of course, well, a great message is, hey, what is the US market doing, right? What is Amazon is the world's biggest process automation company. What are they doing? They announced the first system with integrated OPC UA in their machine healthy system. So they are fully confirmed and aware that OPC UA is a world standard to connect machines for interaction. And Siemens, it's not only that you can use adapters. I just want to make you aware that there are now 11 devices from Siemens with integrated OPC UA into the device. And it's not only the PLC, like the S7-1500. It's an RFID reader, it's CNC control, it's motor management systems, and so on. So here you see a huge commitment that you can start with. Well, at the Hannover trade show this year, Microsoft, we have been guests with this OPC demo wall at the Microsoft booth. And as you can see here, this was a really great message to the attendees. Microsoft, out of the Azure cloud, could immediately connect to all of these devices with different operating systems, different vendors, different jobs in the automation pyramid. It was not only PLCs, RFID readers, temperature sensors, smart meters, and so on. But Microsoft could connect to all these devices without any change in the device. That was really quick. And I put in a picture because we see Erich Barnstein later here as a speaker. This was done before the trade show started, right? He looked young, fresh, and positive, right? So here with his colleagues. But then the trade show started, and they were completely, fully packed all day. So this week he really worked hard, right? Yeah, you earned your money. It was overcrowded. It was one of the most overcrowded parts at the Microsoft booth. So really great success. And what they did is they announced and showcased, okay, how did Microsoft integrate OPC UA in different areas here, 1, 2, 3, 4, into Azure Cloud. I'm not doing a deep dive. It's public available here. There's a URL, a PDF, where you can read all things. But as you see here, there's a deep integration of a gateway, collect data from existing devices, convert them, and then publish it and move it into Azure Cloud. But also here, number one, directly get devices who are directly pushing OPC UA via AMQP directly into the Azure Cloud. So there are a lot of opportunities. And again, Beckhoff at that show integrated stuff from Microsoft directly into the controller, and that was exactly why they have been able to push directly OPC UA publisher subscriber stuff, which Matthias Damm is talking later, directly via AMQP into Azure Cloud. Okay, so which means if you have far distributed devices, then it's easy, then you can push directly from a water treatment to somewhere into the cloud. That makes sense, but inside the factory, I truly believe that you will make use of gateways. And here you see they could directly connect and get telemetry data, but they also could navigate into the devices, read the namespace, and then power on and off a power plug. And so they put in a hair dryer, and for a while everybody thought Microsoft is selling hair dryers, but it was more an example for the connectivity, right? Okay. Interesting for you as a message is, you know that there are specific US regulations that companies who have their headquarter in US are under the law of US government, and on request they have to open their data. And which means the data are, well, because it's your value, it's your data, it's your currency, maybe you do not want to share that data with others, right? And so Microsoft did a really smart move. They were partnering with the German Telekom, and the German Telekom is the owner of the German cloud, and they are just using Microsoft Azure to run and operate the cloud, which means the data are no longer under the roof of Microsoft. Instead, they are under the law from a German-based company, and so a US government is no longer able to touch and get to that information. So now you have, and this is super important for the German industry, of course. They want not others to get access to the data. And here you see again that the 6, so it's a press release, and from the 6 points how Microsoft is advertising for this German cloud, 2 of them are touching OPC UA. One is exactly, hey, we are connected, we have integrated everything. And the second one is that Microsoft helped the OPC Foundation to put everything under open source, but you can recompile it not only for Windows 7, 8, and 10. This is what everybody expected here in the room. But who expected that you can also compile it under other operating systems? Are you talking about that later? Okay. And that's why I say nothing here. Okay. And second, also the Windows 10 team is really drumming for OPC. So here you see this screenshot where they do a positioning of OCF, Open Communication Foundation, and all join. They join together, and Microsoft is placing that, positioning that as integration for consumer IoT, but they are putting OPC UA for industrial IoT. So this is really a huge commitment. And that's now happening worldwide, and this is, of course, giving us great credibility. Okay, now what are the trends? This was the part adoption, so what are the trends? And the trend is definitely, I think what I see more and more, machines and devices are no longer really in future exchanging data, meaning property, properties. They're exchanging more a service, they're communicating in a service-oriented architecture way. What the IT people did for 20 years, I know, so okay. And I give you some examples. Also here from a world leader in the MES area, company SAP. They had a huge demo also on the Hanover Trade Show. There was a live production for this keychain, and it was lot size 1 production, so attendees could type in their own text and select a different color. And VIP attendees got a chip inside, and then everything was sent up to HANA Cloud and so on. And interestingly, the MES part from SAP, this is what I'm talking about, called Planned Connectivity, was directly talking to the XTS transport system from Beckhoff, to the Stolby robot, a vision camera from Ascentix, and the laser printer from CAP. And now you think, yeah, okay, but that's connectivity. I mean, what is new here? All of these devices, all of these machines were only talking OPC UA with each other, but so horizontal, but also vertical to each other. And so SAP was, when for example the transport system sent back an information, hey, I'm here, and I'm at the transport position number 7, I'm ready, then SAP was talking to the robot, please do a pick and place job. The robot was controlled internally on its own, the motion control. This is not what SAP did, of course. Not real time, hard real time, what we think about hard real time is in milli-microseconds. But everything was done via OPC UA method calls, service calls. It was not properties. Which means, just to give you an example, SAP as a UA client called a method inside the XTS transport system, provide an empty transport for the order number 1234 at the position number 7. Then the XTS was moving there, and then calling back, we changed the communication direction. The XTS was acting as a UA client, SAP acting as a UA server, calling a method back, job done with the order number 1234. Right? So the XTS system had no idea, no clue about where am I? Is there a robot or something else doing a job next to me? There was a little bit of tricky stuff with the robot itself, because the robot on the robot arm had a camera, a vision camera. And so when SAP invoked a pick and place movement, the robot was moving into a predefined position, then talking as a UA client to the camera, acting as UA server, please make a picture, give me the position, how I can correctly move 3 degrees to the right and 2 millimeters to the left. And then the robot was doing the pick and place stuff. So for the SAP system, this robot looked like a really super smart robot, right? So the complexity was hidden to the upper MES system. And now you say, hey, but then I'm losing time, right? And this depends a little bit in which industry you are working. If there are machine builders in the room for high-end discrete manufacturing, this never ever would fit. I fully agree. You don't have to convince me. I'm out of that business and I was in that business for a while, right? It depends really in which area are you producing. Do you want that each asset in the product line is only doing jobs on its own? So then you have high-end flexibility. You can move in a machine. As long as it talks OPC UA, you are connected to SAP within 1 hour, and you can really get the first order. So you have super high flexibility. Okay, but if you say I'm in discrete manufacturing and I need to save every milli-microsecond to have more parts at the end of the day, because this is exactly my core knowledge, and the robot has to synchronize speed to the XTS, to the transport system, get something, well, then of course you need a hard field bus or deterministic field bus in between, and you need a PLC synchronizing everything, and then you have this as one machine unit to talk to the upper layer as a smart asset. It depends on you, on the use case. You cannot say this is correct or that's correct. It depends exactly on your requirements. Anyway, and that's a slide also from SAP, they call it SAP reshape the automation pyramid. They are going down into the PLC level. They are not doing hard real time, not controlling, but they are definitely going down into that area. Okay, overall this means the data communication, instead of doing handshake, here's a bit and yes, are you ready? Yes, I'm ready. Here's my product, here's my recipe, or thank you, and so on, which we did over years. This is history. Just make use of a method call, download everything in one, in a fully secured, in a data consistent, even PLC cycle consistent way. Okay, looks like I have to speed up a little bit. Again, there is a companion spec now available, public, for the Auto ID world, and we made also a demo at, well, a year ago. Here the back-off controller was talking with a method call into the Harting RFID reader. Then attendees could use the RFID tag, go to the Siemens RFID reader. It was directly get out of the information and push it here up to the upper layer again, which means they have been semantic identical access to both of their devices. Harting and Siemens were pushing to have the same semantic identical access to their devices, which means this is reducing engineering effort if you integrate that kind of devices into your projects. That's available from stock. You can order that. If I would run a factory and think about should I order this or that device, I would always order something where I can also reduce the engineering time to connect it to my IT world, and which I at the end also could replace, because replacing that with one other device which has better quality or better RFID antenna or whatever is then much more easy. But interestingly, all these devices, and again it's not only RFID readers, it's also 1 and 2D barcode readers, they have method calls. Read tag, write tag, kill a tag, and so on. This is not a bit where you write a bit and then the device is knowing what to do. It's a name. You can call it. It has semantic. It has a meaning, right? Again, web service calls are our future. Then there are a couple of success stories for the horizontal, for water treatment, but also for energy monitoring. That's public, you find it on the OPC web, and also all these devices talk web services or services to each other, OPC UA method calls to each other. And to simplify everything, and maybe well, sometimes I put this slide at the beginning, really think about your own behavior when you buy, for example, a printer on the left side. You go to, I don't know, MediaMarkt or whatever is here in Finland, right? And obviously, this printer has a standardized connector, like a USB connector or Ethernet. And then you think about, why should I buy this or that printer? And there are some criteria, some functionalities, like it's a color printer or black-white only, it's double-sided or single-sided, it can fax and scan and so on, right? It's a functionality, but you never thought about the connection, because that's standardized. And this is exactly happen in the industry right now. On the right side you see the example of RFID readers, which is, again, it's released, it's there. You will see more and more devices coming up. But it's also now, and this will be announced end of this week at the K show. It's a plastic trade show of the injection molding machines. Competitors of injection molding machines from Germany and Switzerland came together and said, we are losing so much time with all this connectivity and security, we want to harmonize. This is not where we differentiate. This is just killing our time. So they came together and made a companion specification for machines, for injection molding machine. And that's now available, and you find the first machines. And now the beauty is all these machines, all these devices can immediately be connected to SAP, to Microsoft Azure. So you have this ecosystem where everybody is benefiting from that. They have easy connectivity, the others have easy access to cloud and can earn money with the data, right? So, and this is exactly where these information models are key for the future, and where all these other organizations define the what. What do we transport? What do we offer as service? And OPC provides the how. How to move these data and information with security on different protocols. And you see that this part is the most critical part for the OPC Foundation to grow into the future. And that's why we do exactly these collaborations, because everybody is benefiting. We see later this day another upcoming companion specification about DEXP. So you have to integrate your logo, right? And now I'm working on the web page that for each of these logos you really find who is my contact partner, what is the content behind. So just go to the OPC Foundation web and you see all that information. The collaboration with VDMA is key, and so I just like to announce that at the next upcoming Hannover trade show next April, the VDMA will provide a brochure together with the OPC Foundation, because right now 3 vertical markets started doing a companion spec, but there are 35 others on the road who also should do that, and that's what we evangelize with them. I think Matthias will talk later on PubSub, so I'm not diving into details here, but this is something again where you learn without changing how my RFID reader, how my injection molding machine is working and what they share for information to the outside world. Because the OPC Foundation is doing more homework and extending the protocol layer below, I have more functionalities in the future. I just have to recompile my OPC toolkit, my stack, make an update into my machine, and then my machine is not only being able to do perfect communication inside the factory, but also to the outside world, to the cloud. So that's coming. And second, what's coming in the future also, yes, OPC UA will become hard deterministic real-time in future in the combination with OPC UA and TSN, time-sensitive networks. And this also has been part of the Intel Keynote, which you can see on a YouTube video here. It will take time. It's nothing which is available next year or within the next 2 years as a real product. Because it's really super complex to configure that kind of networks. If you have an unknown bunch of network nodes and you just do a wish, I want to push data from this node, and please network, allow me to push 200 bytes every 3 milliseconds to that other node over there, and hey network, can you configure yourself to make this happen? This is not an easy job, and you can't do it manually, right? So we need more time there, and we are at the beginning there. But anyway, it's super attractive, and a lot of companies join the OPC Foundation just to be part of that, like Cisco, for example. Cisco is now a member of the OPC Foundation. And then the last trend, I definitely believe that OPC goes down onto chip level. We had that already in 2012, where the Fraunhofer Institute in Lemgo, just as a proof of concept, reduced the OPC stack down to 10 kilobyte footprint. It was just a nano profile, just able to read and write data and browse, no security, nothing. So here 10 kilobytes, you get the slides later on. But today, and this is an announcement from October 13, Hilscher announced an IoT enabled device. It's here their chip, and that chip has multi-protocols on board. It has secure boot, OPC UA and MQTT on really chip level, not on a small motherboard, on chip level. That's really interesting. And here you see their message: IoT communication via OPC UA and MQTT bypassing the PLC. So if you have PLCs which are not able to get all information, exactly what I mentioned at my beginning slide of the Industrial Ethernet Consortium with the IO link data going to a PLC, well, this is exactly where the sensor vendors try to open up that they are able to ship data to cloud, that they can participate to earn money on extra services. This is definitely a trend. Okay. I talked about already OPC UA and TSN, so I think there was a slight mismatch. A lot of companies, 81 participants are in that group, so I'm skipping this here. OPC UA and TSN is definitely not reducing or fighting against field bus systems. Don't start thinking about that. Field bus systems are optimized for bit and byte transport, for motion control, in high deterministic smallest millisecond area. But again, think about all these services between the RFID reader and the MES system or the PLC. And today we cannot calculate the time for that network communication, and this is exactly where TSN helps to reduce the load on the wire. Okay, if you want to get more, you have the OPC brochure on your table. It's also available in other languages. And well, what is the really future of the foundation? Now let's look about 5 or 10 years into the future. Maybe you have not recognized it, but till the beginning of this year, the logo on the OPC Foundation website was OPC Foundation, which is also now, but the statement below was the interoperability standard for industrial automation. Because that's our home ground, right? We are coming from industrial automation, connecting PLCs to HMIs. That's where OPC vision has started. But we already renamed that statement to the industrial interoperability standard. Dot. So we are not consumer. We know that. Consumer area has different requirements. We are industrial. We need a heartbeat. We need live data, alarms, historical data. You can disconnect the cable and reconnect, but the data didn't get lost. That's already built into OPC as really robust environment. But we are no longer just industrial automation. We will grow out of industrial environment into other machines, into other devices, even consumer devices, and this is what you will see end of the year. Okay, that was my presentation. A little bit over time, but hopefully it was valuable. Thank you very much.